I haven't known Rodney for very long, but he is an extremely humble person. So I did just want to say that yesterday morning I was speaking to a few people, and when I mentioned that I was interviewing you, every single one of them said the same thing. And I know that 3 isn't, a statistically significant data set, but they all said, that's amazing, he is the pioneer in artificial intelligence. So I'm very grateful to be talking to you today. You have been involved in this area for over 40 years.
Over 40, yes.
Over 40 years. What originally sparked your interest? Because I'm guessing when you studied, it wasn't really a popular field of study.
No, it actually started. I grew up in Adelaide, South Australia. It started when I was 8 years old. I read a book, and which was in the early '60s, and I just got interested in it, and then spent my whole childhood trying to build robots and computers, and I just kept doing it.
And now you do.
Yes.
And so when you've been in this area for this long, then I'm sure you've seen a lot of developments. What do you think has been the most exciting breakthrough in AI thus far?
Well, I think AI and robotics in general have, of course, benefited greatly from Moore's law, so that things that we found very difficult are now easy. When I wrote my PhD thesis in 1981, over 4 years, my program had looked at 3 images. Now, a PhD thesis, if it doesn't look at 30 billion images, it's nothing. So that's been a complete change in what we can do. The exciting thing that everyone knows about, of course, is deep learning, which broke onto the scene around 2014. But that was after a 30-year build-up to it. It's had remarkable results, but it's not the answer to everything like a lot of people who are new to the field think it is. There's a lot of other things that you have to worry about. And there will be some new hot thing within 10 years. We don't know what it will be yet, but I guarantee there are already papers being written about it, because there's always stuff bubbling. And then every few years, something new pops up and makes us push forward quite a bit. But in general, I think people they've overgeneralized the success of the last few years to think that everything is almost solved, and I think we're still at the very beginning of the journey.
You're a self-confessed pessimist, which I always find unusual in the field of artificial intelligence. It seems everyone is over-optimistic. What do you think is a realistic set of expectations?
Well, I think what we're seeing, and it's gradually happening, is the push forward in machine learning and deep learning has had some practical impacts already. I mean, Alexa, the speech understanding would not have been possible without deep learning. But we're going to see more hybrid systems. It's going to be assistants to humans. Humans are still going to be very much in the loop for quite a while to come. Just 3 or 4 years ago, people were saying, oh, we're going to get rid of all radiologists. It's just going to be AI programs. But now it's settled down to a more sensible thing where the AI program is another source of data for the radiologists. They're able to look at a lot of cases more quickly, get anomalies brought up to them better, but the human is still involved in it. And I think that's where we'll be for a lot of these things for quite a while yet.
And Leda actually referred to that yesterday when she was looking at the comparison between humans alone, machines alone, humans plus machine. It was 96 or 99.6%.
Yeah, I think humans plus machine is the way we should think about it for now. If we go out 50 years or 100 years, who knows? But for our purposes, I think we should look at humans and machines together.
And actually, on that, I guess, spirit of collaboration, I'd really like you to talk about the robotics companies that you founded, which is based on this concept of collaborative robots. Can you talk a bit more about that?
Yeah, well, this was a company called Rethink Robotics, where I'd been manufacturing in China for a long time, since 1997, with another company, iRobot, which we could talk about in a minute. And I saw that there was no way to put robotics. I was seeing in China a coming labor shortage as early as 2005. The contract manufacturers were saying it's just hard to get enough workers. And for iRobot, after Golden Week, we'd be a shift short because people wouldn't come back from Golden Week. So I could see that there was going to be a labor issue in China, but I could also see that we couldn't roboticize Chinese factories in the same way we've roboticized automobile factories, where automobile factories, there's paint and welding, all robots, no people, final assembly, all people, no robots. The Chinese factories were all people everywhere, standing this far apart, and that we had to have robots that were safe to be close to people and be flexible so that the people could change what they were doing. And that's where we came up with collaborative robots, which has now become the pretty much accepted way of thinking about how industrial robots should go forward. If I could just tell one little story. In 2013, at the Automate trade show in Chicago, which is the biggest trade show in industrial robotics in the world, we wanted to have one of our robots on the floor without a cage around it. And the safety people said, there's no way you can do that. You cannot do that. So our head of product got in front of the robot, let the robot hit him on the head lots of times, and eventually the guy said, okay, just this once, we'll have an uncaged robot on the floor. By 2016, there were 3,000 uncaged robots on the floor of the Automate show. It just completely transformed how people think about robots and people in the same space. Mm-hmm. And there, the two things are robots and people sharing the task, and the robot being able to be retasked by an ordinary worker. And that's what we need as robots come more into our lives. It can't be some IT department that tells them what to do. It's got to be people interacting with them. Otherwise, it's not going to be a useful partnership.
And I know that your robots have also been called upon to go into quite a special situation. Would you be able to tell the audience about that?
Yeah, so a previous company, iRobot, which is best known for the Roomba, by the way, just to say how long things take, we had 14 failed business models before the Roomba. And the same year we had the Roomba, we also had the PackBot, which was a robot where we had 6,500 of them in Iraq and Afghanistan dealing with roadside bombs. And people may remember when the US first went into Iraq, there was a question about maybe nuclear weapons of some sort in Iraq. So we had built special radiation-hardened versions of these PackBots. And then we'd had them operating with soldiers, ordinary enlisted men and women, operating these robots by 2011, we'd had them there for 9 years. Then Fukushima happened. The earthquake happened, the tsunami hit the Fukushima Daiichi plant, which had 6 reactors. Only 2 of the 6 were shut down easily because those 2 were up on a hill. The other 4 got incredibly damaged by the actual tsunami hitting them. And after about 7 days, when TEPCO, Tokyo Electric Power Company, and the Japanese government still didn't know what was really happening, they called on us. I was still on the board of iRobot at the time. This is March 2011. And within 48 hours, we had 6 robots in Japan, got the TEPCO people trained up, and those robots were used to shut down the remaining reactors and save them. And actually, that, in all the things I've done in my life, that feels the best of being able to help with that. I visited Fukushima in 2014. It's a 50-year cleanup effort, a lot of robots involved, and they're all collaborative robots with people and robots.
And so this might be a stupid question, but in terms of the radioactivity then, is it just specific? Was it just because your robots had been previously...
Yeah, some of the ones we sent had been radiation hardened, and they went into the most extreme parts. Some of the others had not been radiation hardened, and they were used as a Wi-Fi sort of hotspot to reach out to the further robots. The Fukushima was a 40-year-old nuclear power plant design built by GE, and it had no digital infrastructure whatsoever, just gauges that you had to go and look at, and our robots went out there, looked at them with a camera, hopped the data back, and that's how they got to understand what was going on. Because those areas where the extreme robots were, it was about a 2-minute lifetime for a human in that radiation environment.